Welcome aboard, space crew. Today's mission takes us deep into the mysteries of the universe. So hold on tight as we blast off into the stars.
What if your brain and the universe were built from the same blueprint? Galaxies connect like neurons. Blood vessels branch like cosmic filaments. Cells collapse into order the way stars are born, and even death recycles matter the same way in bodies and supernovae. Coincidence, or a shared set of hidden rules? Because once you start lining them up, biology against the cosmos, the similarities don't fade. They multiply, and the first one begins at the largest scale imaginable, with a universe that looks suspiciously like a brain. Number 15. The universe is built like a brain. What if the universe doesn't just contain intelligence, but is actually shaped like one? When scientists zoomed out to the largest scales, they expected randomness galaxies scattered without a pattern. Instead, they saw something familiar, a vast cosmic web. Turns out, even the universe doesn't like being unorganized. It has a layout. That layout mirrors the human brain. Neurons act like dense nodes, axons like filaments, and gaps like voids. Even more striking, when researchers compared how these systems grow and store information, the math matched despite being separated by 27 orders of magnitude in size, different scales, same rules. And that leads to a bigger question. If the universe organizes itself like a brain, then we're no longer just comparing biology against the cosmos. We're changing our trajectory, asking what else might a system like this be capable of? Number 14. Blood vessels and cosmic filaments follow the same math. If the universe behaves like something alive, could it have its own circulation system? Inside your body, blood vessels branch with extreme efficiency. Large arteries split into smaller ones, then into capillaries, all designed to move oxygen using minimal energy. The universe does the same thing. Cosmic filaments act like giant arteries, funneling gas and dark matter into galaxy clusters. Simulations show the equations match blood flow through tissue. Same efficiency, same logic. From veins in your arm to filaments between galaxies, nature keeps reusing one blueprint. Number 13. Cells and galaxies both form from collapse. So then, how does order emerge from chaos, inside a cell or across the cosmos? Galaxies don't start organized. They begin as diffuse clouds of gas and dust until gravity pulls everything inward, heating and shaping it into structure. Cells form the same way. Molecules clump together through physical forces, separating into organized structures like organelles. No designer, just physics. No meetings, no blueprints, no let's circle back emails. Collapse isn't destruction, it's creation. Gravity builds galaxies. Biophysics builds cells. Same story, different scale. And once you see that pattern, it becomes hard to ignore what comes next. Number 12. Life and stars recycle the same way. What if death isn't an ending but a transfer? Massive stars don't fade quietly. They explode as supernovae, scattering elements like carbon, oxygen, and iron into space, the raw materials for planets and life. Biology mirrors this, just faster. When organisms die, decomposers break them down into nutrients that feed new life. Nothing is wasted. The calcium in your bones was forged in stars. Matter doesn't disappear, it waits for its next role. And that makes you wonder, what force keeps this endless recycling in motion? Number 11. Both rely on energy gradients to survive. So what actually keeps stars burning and cells alive? What's the shared fuel behind it all? Inside your body, every living cell survives by maintaining an energy imbalance. Think of it like a charged battery. Cells create chemical gradients to produce ATP, the molecule that powers life. The moment that gradient collapses, life stops. Stars follow the same rule. They shine because of massive energy differences between a super-hot core and the cold emptiness of space. Galaxies grow as matter flows from low-density regions to high-density ones because even in space, nobody likes being in the empty corner. Both life and the universe survive by riding energy downhill, delaying equilibrium for as long as possible. Structure exists only where energy is uneven. And that raises a chilling thought. If energy differences disappear, what happens to complexity itself? We'd be in an uncharted sector then. Number 10. DNA and the universe both encode history. What if the past never really disappears? What if it's quietly written into everything around us? DNA is often seen as a blueprint for life, but it's also a historical record. Every mutation, survival trick, and ancient disaster is etched into the genetic code, waiting to be read by scientists billions of years later. The universe does the same thing with light. Because light takes time to travel, every star we see is a snapshot of the past. The cosmic microwave background is literally baby photos of the universe. Astronomers read history through ancient light, just as biologists read it through DNA. Different mediums, same idea. The present is built from stored memories of the past, and once you realize that, evolution itself starts to look much bigger. Number 9. Evolution mirrors cosmic evolution. But is complexity an accident, or is it the direction reality naturally flows toward? The universe began as something incredibly simple: a hot, uniform soup of particles. No stars, no planets, no chemistry, just raw ingredients cooling over time. Gravity slowly shaped that simplicity into stars, then planets, then environments capable of chemistry, and eventually life. Biology mirrors this path. Life began as simple single-celled organisms, then merged, specialized, and grew into complex beings with brains and consciousness. From tiny blobs to overthinking everything. In both cases, energy plus time turns simplicity into complexity. The universe didn't just allow evolution, it followed it. Which makes you wonder, is complexity the universe learning to know itself? Number 8. Fractals rule both scales. Why do patterns repeat no matter how far you zoom in or out? Look closely at a lung, a blood vessel, or a tree branch, and you'll notice something strange. Each part resembles the whole. These repeating patterns are called fractals, and biology is full of them because they maximize efficiency. Now, zoom out to the universe. Galaxies cluster like branches. Cosmic filaments split and reconnect just like neural networks or root systems. The same geometric rules appear at radically different scales. Nature doesn't reinvent patterns, it reuses them. From your bloodstream to the cosmic web, reality seems to prefer shapes that repeat endlessly. And once you see that, it becomes harder to believe we're separate from the universe at all. If this is already bending your brain a little, do me a favor. Tap like so the algorithm knows you're enjoying the cosmic ride. And if you're still watching, you're clearly one of our people. So go ahead and subscribe before the universe realigns and you forget. Number 7. Life clusters, so does matter. Now, why do you think being alone is so rare in both life and space? Well, in biology, survival almost always means sticking together. Cells cluster into tissues, tissues form organs, and organisms gather into families, herds, and societies. Cooperation increases strength, efficiency, and survival. The universe plays by the same rules. Stars are born in clusters, not in isolation. Those stars group into galaxies, galaxies into clusters, and clusters into vast superclusters. Lone atoms drifting in empty space rarely build anything meaningful. Complexity needs company. Whether it's cells exchanging signals or stars bound by gravity, grouping is the first step toward structure. And once clustering becomes the norm, balance becomes the real challenge. Number 6. Both depend on delicate balance. What keeps complex systems from collapsing or exploding out of existence? Life survives only within narrow limits. Your body carefully controls temperature, acidity, and chemistry. It's basically 24/7 internal customer support, fixing problems before you even realize they exist. No holidays, no breaks, just constant adjustment. Push it too far, and the system fails. This constant fine-tuning is called homeostasis. Stars live on the same knife edge, Gravity pulls inward, fusion pushes outward, and stability exists only when those forces cancel perfectly. Too much gravity? Collapse. Too much fusion? Explosion. Neither life nor stars are passive, they survive by constantly correcting themselves. Stability isn't stillness, it's an effort. And sometimes, despite all that balance, catastrophe still strikes. Number 5. Extinction events echo cosmic catastrophes. But what if destruction isn't the opposite of creation, but part of it? On Earth, mass extinctions wipe out dominant species, like the asteroid that ended the dinosaurs. Brutal, yes, but it also opened the door for mammals and eventually, us. The universe does the same thing. When galaxies collide, their graceful shapes are destroyed, but the chaos ignites massive waves of new star formation. Supernovae erase solar systems, yet create the heavy elements needed for planets and life. Basically, the universe flips the table, then builds something better. No apologies, no regrets. In both biology and cosmology, catastrophe clears space for innovation. Destruction doesn't end the story. It rewrites it, which leads to an even deeper truth about information itself. Number 4. Information is never truly lost. If things disappear, where does their history go? In biology, information lives in DNA. Even when species vanish, traces of their genetic code survive in descendants or ecosystems shaped by them. The past leaves fingerprints. Physics says the universe works the same way. According to quantum laws, information can't be destroyed, only transformed. Even black holes, once thought to erase everything, may slowly return information back to the universe. Life and cosmos both store memory in physical form. Nothing meaningful truly vanishes, and that persistence of information helps systems push back against chaos itself. Number 3. Both systems resist disorder locally. And if entropy always increases, why does order exist at all? Life seems to break the rules by creating structure cells, bodies, cities. But it does this by exporting disorder outward, releasing heat and waste to stay organized. Cosmic structures do the same thing. A solar system forms from chaos, becomes highly ordered, and maintains itself by radiating energy into space. Both cells and galaxies are pockets of order fighting entropy locally, even as the universe trends toward disorder overall. Order survives by paying a price, and timing determines whether that fight is even possible. Number 2, timing is everything. Then, why do things fail even when all the pieces seem right? In biology, timing is ruthless. Miss a developmental window or breeding season, and survival drops sharply. Life needs the right conditions at the right moment. The universe has its own timing rules. Our sun formed during a sweet spot when heavy elements were abundant enough to build rocky planets and complex chemistry. Too early, and life wouldn't stand a chance. Both stars and species depend on perfect timing. And when you line all of this up, one final question becomes unavoidable. Number 1. Both may be expressions of the same laws. What if life isn't separate from the universe, but inevitable within it? Would it be all systems go toward a reality where complexity isn't rare, but expected? Across every scale, the same patterns keep repeating: clustering, flow, balance, collapse, and resistance to entropy. These aren't biological tricks or cosmic coincidences. They're the same physical laws playing out in different materials. Cells and galaxies aren't opposites, they're cousins. Life isn't something added to the universe. It's something the universe naturally does. From neural networks to cosmic webs, reality keeps solving problems the same way. We aren't just in the universe. We are one of its patterns, thinking, observing, and finally realizing where we came from. Before we go on, quick question: do you think these similarities mean life is designed, inevitable, or just a beautiful coincidence? Drop your theory in the comments. And hey, if you're made of stardust and not floating through space by accident, hit that subscribe button. Smash like if your brain just made a cosmic connection, because this channel is where biology and the universe collide. Until our next mission, Keep your eyes on the stars.
Our mission is complete, and we're coming in for landing. Stay aboard and join the crew again as we continue unveiling the stars.